Hey, Assalamualaikum and good morning to everybody. So today we will start our first class on heat transfer, code BMMH 3553. So welcome to heat transfer class. So hopefully that everybody will be listen and try to understand it because heat transfer is not it's not so easy and it might be a killer subject, but if you understand well, and it could be a very easy subject for you to score. Okay, so hopefully everybody now in fourth year, right? So fourth year. So hopefully that you have a very higher motivation to score this subject. Okay, so let's continue. Okay, basically what will be covered? This is what will be covered: heat transfer conduction, one-dimensional conduction, multi-dimensional unsteady states convection. Some chapter maybe we only touch a bit, but some will go in detail. Okay, so basically, okay, what will be discussed on this today's slide. So basically we will discuss on general introductions, and then mode of heat transfer means how the heat being transferred from one place to another place, and so how many transferring type that it have, and then we go detail in conductions. It's one of the modes, and then we go in thermal conductivity. What is the thermal conductivity? Okay. So our objective today is to understand how thermodynamic and heat transfer are related to each other, and then distinguish thermal energy from another form of energy, and heat transfer from another form of heat transfer. So we try to distinguish two things actually, and then understand the basic mechanism of heat transfer, which are conduction, convection, radiation. So this is three basic things. This is the first one: conduction, convection, and radiation. So just remember it well. Okay, and then we have a Fourier's law of heat conduction. Okay, so heat conduction is happened because of this law actually. We use this law, Fourier's law of heat conduction, Newton's law of cooling, this is the law for convection, and Stefan's Boltzmann constant of radiation. This is actually this is all the names of the ones that found or do the formula for each of heat transfer type. Okay, so thermodynamic and heat transfer. So I know you are already learned thermodynamic, so this is it's a bit the same actually. So we'll go in detail. So the first one is heat. What is the meaning of heat? Heat is a form of energy that can be transferred from one system to another as a result of temperature difference. So meaning that when there is temperature difference, the heat will be transferred. When there is no temperature difference, mean if you have example your temperature is 35, another one is also 35, so no heat will be transferred between you. So you will not feel any hot. Okay, for example, you are in front of aircon, outdoor unit. Okay, so the aircon is maybe 20, I'm not sure, maybe 40, maybe 40 outdoor, maybe 40 degrees Celsius. So normal temperature human body is 36, 37, and so because of there is a difference of temperature, the heat from the outdoor unit will transfer to you, so you feel a bit hot. But if there is no temperature difference, the outdoor unit is 37 and you also are 37, you will not feel any heat, or you will not feel anything, if you are near to that outdoor unit. Okay, and then we have thermodynamic. Thermodynamic is concerned with the amount of heat transfer as system undergoes a process from one equilibrium state to another. So basically this is actually only focusing on the amount of heats. Okay, amount of heats. Besides, heat transfer is actually focusing on the rates. Okay, this is amount kilojoule, this is rate kilojoule per second, okay, of such energy transfer as well as duration of temperature. The temperature of energy as heat is always from higher temperature medium to lower temperature one. Okay, this is what I said before. The two medium means the surface, surface or solid. You have whatever medium you have, solid fluids. So that mediums, the heat is being transferred from higher temperature to a lower temperature. So it's not from lower temperature to the higher temperature. This is from high to lower temperature. Heat transfer stop when the two medium reach the same temperature. So for example, when you have a hot cup of coffee and you put on the table, for example here you put on the table, and this heat is being transferred out to the cold environment, which is 20 degrees Celsius. The heat will be stopped if the hot coffee become 20 degrees Celsius, same as the cold environments. So there is no heat transfer between them. Okay, heat can be transferred in three different modes. Okay, this is conduction, the first mode. Second mode is convection. Third mode is radiation. Okay. Let's have a look. This is actually insulator to prevent the heat being transferred out. Okay. So we insulate it with the, I don't know what it is, aluminium. Not sure what kind of something they have. So it being insulated so the heat will not be transferred out from the hot coffee to environment. Application of heat transfer. Basically, heat is being transferred from this is human body lah. Human body, when you are cold and you sit together, then heat will be transferred from one to another. For example, here, then you feel warm. You sit nearby to your friend or your father's siblings and so on. And then we have air conditioning system. This is heat is being used to transfer from inside to outside. And we have heating system. Heat is being transferred from outside to inside. So we heat the classes, the medium, the office. And the outside means from the whatever burning fuel that you have, unless the outside is very hot, and then you transfer to hot. For example, we had you could collect the geothermal energy from the down the earth, and then you could transfer the whatever heat that you have, or from the sun you could transfer the heat that you have towards and inside of the building. But here normally they burn the gas, fluid, so on, or coal, coke. And then we have electronic equipment. Okay, you need electronic equipment. Actually, we need to cool it down. So heat is being transferred from the circuit to environment. This is power plant. So when we have a power plant, this is already been heated. Then we need to cool it down. This is cooling towers. Okay, to cool it down. And we have refrigeration system to not cool, but then we have to freeze them. Okay, below 0 degrees Celsius. So this is application of heat transfer. Engineering heat transfer. Heat transfer equipment such as this is type example heat exchanger, boiler, condenser, radiator, heater, furnace, refrigerator, solar collector are designed primarily on the basis of heat transfer analysis. So this is whatever we have above here actually is first come out from the experimental and analyze, then they come out with the equipment. Heat transfer problem encounter in particular can be considered into groups. Okay, nowadays and the problems of heat transfer, basically we have these two. The first one is rating, how much heat is being transferred, and the second one is sizing. For example, we need heat to be transferred very fast, but we need a very small fan, and so this is. And for example, we need to cool the room, your study room in your house. You need to cool it down, but you need a very you need to cool it down very fast, but you need a very small one, perhaps 0.5 horsepower aircon. Could it be done? And this is the problem lah. Okay. So kalau in a big company, for example, this is why you need so much cooling towers? Cannot be only one. Perhaps one is already enough to cool this whatever we have here. So this is site rating and sizing problems. And then we have engineering device and process can continue their experimental testing and analytical by this is the process of when we have the device that we could experimentally test to find what are the heat transfer rate rating and is it okay or not. And then we have this one is analytical. Besides we have experiment, we also do calculation. Okay, calculation, we try to calculate is it okay or not with the whatever design that we have. Experimental approach, this is experimental. We measure it, and then perhaps there is limits of time that we could measure. Is there any errors? However, this approach is expensive. Expensive when we want to do the experiments. Involve money, time consuming, and electricity, and then for analytical approach, including numerical approach. Numerical means we use software. Has advantage because it's fast and inexpensive, but expensive for to buy the software. Okay, but for long run is inexpensive. But the result obtained are subject to accuracy. Okay, somehow in numerical, we doesn't know whether this is correct or not, because some characteristics we are only assumes. So if you should do both way, analytical and experimental, so you could tally whatever you have. Yeah.